we're going to look at the prime factorization of 5040 two different ways. We're going to look at it in a similar method as we did our last example for the prime factorization of 72. We're going to start with the smallest possible prime that isn't 1, because 1 isn't a prime, that is going to evenly divide into 5040 and work our way down the factor tree. So if we start with 5040, I can see that it is an even number because it ends in a 0, and I know that 5040 divided by 2 is going to equal to 2520. 2 is a prime. Excellent. We know that that arm of our factor tree is finished, and I'm now working on this number of 2520. So if we keep going with our method from our previous example, the smallest prime number that will divide evenly into this is going to be 2 because it's a nice even number. If I decide that I'm going to cut 2520 in half, I'm left with 1260. I have a nice 2 as my prime. Again, 1260 is even, so I'm going to go with 2 multiplied by 630 as my two factors for that number. Notice all the way along I'm squaring up my prime numbers. Again, 630 is even, so now I'm going to get 2 multiplied by 315, an interesting number finally. I can see that 315 is not prime. Is not prime. Also, it's not even. So I can't continue with 2's. So the next number on our list logically would be 3. I'm going to take 315 and I'm going to divide it by 3, and I see that it is nicely and evenly divisible by saying 3 multiplied by 105 is 315. Now we know 3 is a prime. You can see this is going to take a long time and it gets a little bit messy. So we know 3 multiplied by 105 is going to equal to 315. I know that 3 is the prime, so that arm of my factor tree is done. I'm going to cross this out so I don't accidentally count it twice at the end, and I'm going to move on to the number 105. It's not even, so 2 is not going to work evenly into that one, but let's try 3, and I can see that that's going to be 3 multiplied by 35 is going to equal to 105. I know 3 is a prime, so I'm going to stop that arm of our factor tree. Next, I can see that 3, we could try 3, but it doesn't work evenly. 5 does, which is our next prime, and 5 times 7, lucky for us, are both primes, and we have finished our factor tree. So we have 5040 can be written as 2 times 2 times 2 times 2 times 3 times 3 times 5 times 7. Cleaning that up a little bit, we get 5040 is equaling to 2 to the power of 4 multiplied by 3 squared multiplied by a single 5 and a single 7. What we're going to try now is to work a little bit faster. You can choose whichever method you like. They are both going to get you to the same answer, but that took a long time. Maybe let's try and work both arms of our factor tree at the same time. You could choose any number that you think is going to nicely divide into 5040. I see 10. It's not a huge number, but I do know that because it's got 0 at the end, it's definitely going to be 10, or 10 is going to be one of its factors. So I know that 10 multiplied by 504 is actually equaling to 5040. I cannot circle or square either of these because neither of them are prime. So what I'm going to do is I'm going to work both sides of my factor tree at once. Now, 10, we know that that's 2 times 5, and lucky for us, both of those are actually prime. So now this arm of our factor tree is already finished. 504, we have options. 504 we know is even, so you could write 2. We could try 4, we could try 6, we could try 8, we can try a bunch of even numbers because I know that it's even. Not all of them are going to work, but some will. I'm going to go with 8, just for fun, just because it's a little bit bigger than 2. So if I took 504 and I divided by that by 8, I'm going to get 8 and 63. Okay, neither of them are prime, but we do know that we could break down 8 quite easily into a prime number of 2 multiplied by 4. Okay, and I also can break down 4 quite easily as 2 times 2. So those ones were nice, easy mental math that we could see. The 504, we might have had to use our calculator. Now, 63, I know that's a multiple of 7, so I can say that that's 7 times 9, and that's even better because 7 itself is a prime. Now, 9 is not a prime, so I'm going to break that down into 3 times 3. And now we've got that prime factorization all the way broken down into the smallest prime numbers we can. I have to double count here. I've got 1, 2, 3, 4 2s, so we can write the same thing as 2 times 2 times 2 times 2. I've got 1, 2, 3s. I've got 1, 5 and 1, 7. So again, I actually get the same prime factorization. There are many different ways to do it. You can choose the first method, which was quite systematic. You don't have to think too hard. You just keep going up by the even numbers by 2. And if it's odd, try 3, try 5, and keep going. Or you can get a little more adventurous and try your prime factorization working both arms of the tree at the same time.